Hi, everyone. Thank you for being here at the end of today, hanging in with us for this last talk. My name is Diana Chen, and I'm a Senior Solutions Architect at AWS for the last 4 years. And I have the pleasure to share the stage today with my colleague, Dirk.
Hello, I'm Dirk. I'm a Principal Solutions Architect with AWS. In my day job, I work with software companies on their multi-dimensional transformation. And my hobby horse is everything around integration architecture. As Diana already mentioned, it has been a long day. It's the last slot for the day, so we're really grateful that you still came. And we also understand we are between you and the beer, so we give our best to make it worthwhile. We actually have a ton of stuff today. It could easily fill entire books or a course of lectures, but let's see how it goes. So, event-driven architecture, or EDA. For some reason, it gained quite some popularity during the past years. Why is that so? Because the concepts have been around for a few decades already. But there might be two reasons why it gained popularity. The first one is the rise of cloud-native serverless managed services that just make it more accessible to build event-driven architectures, particularly looking at integration services. And the other reason could be, it is a divide and conquer architectural style. So it suggests that you have independent systems that send out events, other systems receive events and react in whatever way. And like 10, 15 years in the past, already there was a rise of another divide and conquer architectural style, which is microservices, or also self-contained systems. And that certainly also accelerated the popularity of event-driven architecture. But what are EDAs in the first place? So on the first surface, it could look quite simple, right? We have a producer, they send out events. We have a consumer, they receive events, and in the middle there's something like a broker or a channel. And in many cases, you would actually also expect to have multiple consumers that are interested in the very same event. So that looks super simple at the surface, but your experience probably also tells you under the hood it is a bit more complicated. There are always trade-offs and costs that come with it if you gain something from it. And then another question, what are events in the first place? And the simple answer is technically they are messages, but with a certain intent. From enterprise integration patterns, we can learn that there are 3 message intents. The first one is command, the second one is document, and the third one is event. So what type of message intent could be relevant for event-driven architectures? Anyone a guess? Maybe event messages. Yes, exactly. So that's what we are interested in. And that is the first mental transformation that you have to adopt when you want to go with event-driven architecture. You need to say goodbye to your beloved request-response pattern. Now you only send out events with no response expected whatsoever. This and several other trade-offs under the hood are important to be understood to manage the expectations. And this brings me to one of my favorite insights, and I also call it the beware of the face healer principle, that no architecture decision you take comes without trade-offs. Or in simple words, there's always something that sucks. And as an architect, you need to identify all the options on the table and then pick the one that sucks less than all the others. And this is also the case for event-driven architecture. You gain a lot of benefits, but you also need to consider the trade-offs and be prepared for that, so that the expectations are also met. Now, you can probably easily imagine that adopting an event-driven architecture is nothing that just happens overnight. It is a journey like with several other transformations you go through. And it has ups and downs, obviously. So the ups are all the benefits and the insights that you get from it. And the downs are the trade-offs and the pitfalls that you might fall into. We will have a look at those during this session. But the interesting thing, or the thing to remember, is there is a journey. Now, if we take it from the benefits and the initial design, why should we think about events in the first place? So the difference between events and state is that events tell a story. But why should that help us? The first thing on the left-hand side is one of the decisive factors here, loose coupling. So the thing is, when you use an event-driven architecture, when you just send out events, you don't expect any responses or so. That implicitly reduces the coupling between your involved systems. And that buys you a lot of other cool things, like scalability. The more independent and less coupled your systems are, the easier it gets to scale them out independently. And the same applies also to extensibility, so the evolution of your systems. It is, as I already mentioned, a divide and conquer architectural style. And why do you apply the divide and conquer principle? Because you want to cut down a complex thing into smaller things that are easier to manage. And last but not least, the way how you integrate these systems in your event-driven architecture, and we will see that in a bit, it allows you to increase the overall availability of your application. Now, you might ask, Dirk, where should we start with this journey? And that's a very good question.
Indeed. So where should we get started? What we see when we observe the journeys that customers undertake is that there are basically two ways we can start. The first one is we go straight into implementation, basically taking a bit of a shortcut in our journey, and we start producing events, and we have our producers and our consumers. And the next one is that we take a step back, we take a moment, and we start to think about the behavior of our systems and how we can actually integrate them. So let's take a look at both of them, because they will have quite some differences in the journey that they make as you adopt one of those. And let's start with implementation first. So when we start implementing our event-driven systems, we see this immediate jump in value. We have our initial producers and consumers, and we are very happy because we can add more consumers, and we can scale our architecture. We can deploy systems independently and go to production independently. But we also observe that very quickly this value that we gain tends to stall. And we ask ourselves, why is that? And if we plot the complexity over time, we also see that it tends to increase quite a lot. And the reason for that is that, yes, we had our initial producers and consumers, and we added more. But there were also several things that we kind of overlooked as we started. We made a lot of assumptions that we didn't really verify. We lacked the standards, so we now have a lot of events flowing, and we don't really know what those events are, what is inside those events. And suddenly we have these unclear domains. So what is the boundaries between our systems and our domains? That has not been defined. And complexity can grow very quickly. And to put an example of how this might happen is you have this very simple architecture displayed here. And we have our producer, which is the order service. That's the orders domain. And we have our event bus, any type of message broker. And we have downstream consumers. In this case, we have 3 different systems that are interested in hearing or learning from events from the orders domain. And as things start to happen in our orders domain, we start to want to communicate those things, and we say we can raise an order-created event. So we just do that, right? We go ahead and put out some code, and this is an example of how our order-created event might look like. At the top, we have the detail type. This is an event example with Event Bridge, but it would be similar with any other event broker. Detail type, in the case of Event Bridge, indicates kind of the event name. So what kind of information am I passing along in this event? Well, that an order has been created. That's pretty simple. We also have the source, which is basically which context or which domain has raised this event. And then we have our payload. So in the detail object, we have included the order ID and the user ID, and we think this is pretty representative of an order that has just been created. And it probably is. So things start continuing, and we see more things happening in our domain that we want to model, and we raise next another cancel event because downstream systems are also interested in that. Again, we just put out some code for our event, so a JSON payload. And here we also include things like a reason for the order having been canceled. And we say it's no longer needed. And that seems fair enough. We think consumers should be able to understand that. And we also add a type, and we say TW. And can anyone guess what TW means? Literally, no one will know outside of the orders domain what TW stands for. And what is happening here is that the orders domain has started to leak implementation details. It starts to send in the event things that only concern to its domain. It's starting to send as public information its public language. We also in the payload see that we've included a user event. Previously, we only had the order ID and the user ID. And now for the user, we have the first name and last name. And maybe this is fine, but maybe we're not really allowed to pass personally identifiable information across contexts in our organization. We didn't really validate that. And the cycle continues, and we could next include an order updated event. And then things start to become complicated in that our systems have grown into this very ad hoc ecosystem. We have more domains, and we don't really have clear boundaries anymore. And what also tends to happen is that we see this unclear domain language emerging. And what it really means is that across the organization, we start having different understandings for what we thought was the same thing. And if we take the example of an insurance company, the definition of the policy, for example, we as the development team, we think we know what the policy is, and we say, well, the policy is this and that, and it belongs to a user. And as soon as we integrate with another party, for example, the insurer, then they come along and say, hey, no, that's not exactly what the policy is. The policy belongs to us, the insurers, and the user is just a part of it. And as we go along, integrated with yet another party, like the underwriter, those that assess the risk of granting a policy to someone, then they have a completely different understanding, yet another one, of what the policy is. And this is some of the assumptions that we made. And what really ends up happening is that we end up with this big ball of mud. And this is a term coming from domain-driven design. And it tries to say that we have really unclear context. We don't have a common language in the organization. And we often see private information belonging to specific domains flowing across the organization as if it were public information. We didn't define a ubiquitous or universal languages for context to communicate. And there is this phrase from Alberto Brandolini, the author of Event Storming, and it tells us that it's the developer's misunderstanding and not the domain's expert knowledge that gets released into production. And this happened partially because we went implementation first, and we didn't take care of fostering that collaboration between developers and domain experts and business experts. So we can do better than that, most likely, and Dirk will explain how.
So yeah, let's look a little bit at that understanding or misunderstanding behavior, because what you probably want to avoid is that big ball of mud that Diana just showed. So our proposal here would be to first get a really good understanding of the behavior of your system and also the events that wander around. What do you need for that? You need to have the domain experts and the stakeholders that actually understand what's going on. You need to bring them into one room and then collaborate to find out, okay, we can identify these are the events that happen. And one very important thing is also to find a common language. To avoid the misunderstanding, you have to have a common language so that all technical terms have the same meaning for everybody. A practical implementation for that would be event storming. Anyone here who did event storming already at their jobs? A few? Okay, great. So going into the details of event storming is, again, it's a talk on its own, but this is exactly what you then do. You bring all the domain experts and the stakeholders in a room, you bring a lot of stickies, and then you identify the systems the commands that are available, and then the events that are created. You put them into a timeline, and from that on, you get a good understanding what is actually going on within your systems. And once you got that understanding, you should then also start implementing your event-driven architecture-based application. Now, I've talked about messages already a little bit in the beginning, and let's dive into it a little bit more. So, the foundations for the integration of the systems in your event-driven architecture. Let's start again with the order service. From an end-user client's perspective, you probably want to stay on common grounds and have an application that uses the request-response pattern for the communication with your order service. And that might be a synchronous request-response. So that means the client waits until the order service does its job, until it returns the response, while the client holds the line. And that may be a lousy user experience if it takes quite long. So typically then you would switch to the asynchronous request-response pattern, where the server downstream just sends back an acknowledgement to accept it, for instance, in HTTP. And then later, when the result is there, you can either poll it or you can inject it with a push notification to the client. But under the hood, in the backend, this is where the EDA magic then can happen. So from that moment on, from the order service, only events are sent out further downstream. You see that event bus, we will also understand a little bit more about what that is in a few minutes. But the main thing is here, events are being sent out, no response is expected whatsoever. It is immutable data, and of course, the potential consumers can decide if they are interested in such an event or not. And just to make it clear once more, what we're interested in an EDA is exactly what we see on the left-hand side. One-way communication, not request response, right? That we can still do between end-user clients and so on, but not in an EDA. Right, so integrating two systems with each other, how hard can it be? It is quite easy to draw a line between two boxes, but then there are tons of integration options. And for some reason, we are kind of stressing on messaging as an integration option all the time. And we will also understand very soon why that is the case. We have a few fundamental integration patterns that are based on messaging. We have point-to-point integration with queues, publish, subscribe with topics and buses, and then we have streaming implemented by streams. What a surprise. And number 2 and number 3 are both fan-out integration patterns. That means multiple consumers can receive those messages. And then we have advanced integration patterns that look after common coupling traps or other pitfalls, and domain-driven design questions that might come up while you design your event-driven application. Now, I mentioned coupling already a few times. It's actually integration's magic word. And that is also something that decides about the variability between your two systems. And also, decoupling or coupling is not binary. It's not an on-off switch or so, right? There are different levels of coupling. And if the level is 0, then there is no interaction between two systems. Also, coupling has many dimensions. The ones we are looking at in a second with some examples are the temporal dependency and the location dependency, which is more or less runtime coupling. But also design time coupling is quite interesting and relevant. And I find this insight from our colleague Gregor quite helpful, which is the appropriate level of design time coupling depends on the level of control you have over the endpoints. If you want to integrate two services that you own, you can afford more design time coupling between those two systems than if you need to integrate with a third-party system, like an external payment service provider, where you probably have no control over the endpoint whatsoever. But what about runtime coupling? So generally, when people start setting up to divide and conquer architectures like microservices, they start with adopting what they know already from a monolithic application before, which is synchronous function calls. And that typically translates into synchronous requests over the network. Now, the first thing is when you want to reduce the runtime coupling, so the temporal coupling, while you wait for a response for a downstream system, you switch to asynchronous integration. You can also do this with HTTP. Let's assume now in this architecture we already sent events downstream over an HTTP API. But what are the implications now? So the fulfillment service in this case just needs to live with all the events that are pushed on it, and either it has the scale to do it or not. Also, what if something fails at the fulfillment service? Is it the order service's responsibility to do retries, or is it the fulfillment service responsibility? And additionally, the order service needs to know, okay, there is that API resource on the fulfillment service. It has this URL, and this is the way how I can access it. And of course, there is the availability dependency, right? The order service cannot communicate with the fulfillment service if it's down. And this is where queues kick in. So queues have a very interesting characteristic. They can buffer messages for you. That means the fulfillment service in this case can consume the messages that are buffered in the queue at a desired rate. That's also very nice for flattening peak loads. So in that respect, the queue is a traffic shaper. Also, having the queue in the middle between these two systems decouples them from each other in a sense that the order service doesn't have to know anything about the fulfillment service anymore, and vice versa. Now, if something fails when the fulfillment service consumes a message from the queue, it is isolated there. The order service doesn't have to care at all. And the important thing to remember here regarding queues, it is a point-to-point integration. That means there's one consumer for every message, which is not a bug, but a feature, because it supports the concurrent consumer pattern, which is the last bullet point here on this list. That means if there's a lot of load on the queue, you can just launch more processes to consume that additional load, which comes in very handy. And again, because that queue is in the middle between the sender and the receiver, it also removes the availability dependency. So you can also take the receiver offline for planned or unplanned maintenance, or maybe it just struggles under the load or so, then the sender can still send out messages. So Amazon Simple Queue Service, or Amazon SQS, is the go-to service when it comes to queues in the cloud, on AWS at least. So it is a serverless managed service. It comes with a super simple API, and it just makes it super easy to implement the point-to-point messaging integration system. And with all the things that give you benefits, there's also a trade-off. And I just wanted to make you aware of one thing that you should also take into account when you work with queues. They typically require flow control, in the sense when you have slow consumer constantly and fast producers constantly, then your queue will fill up. So there are two things that you can do about it. You can either add a time to live to your messages and then shed them, get rid of them eventually, or you acquire, you apply producer flow control, which means you put back pressure on your producers. Tell them, okay, please slow down, stop the message production for a bit. Like if you go into a coffee shop and all the baristas are busy doing coffee, you have to wait a bit until the next barista is available to make your coffee. So just to keep that in mind. As I said in the beginning, in many cases, you would also expect that there are several consumer services, systems that are interested in any given event. The invoice service, the fulfillment service, the forecasting service in this case. If you again go and start with APIs, you have all the drawbacks that we had with that one consumer party. But now you also have the multiplication of the effort to send out those event requests to the downstream systems. And you have to know, you have that location dependency, you have to know the addresses, the URLs of all those API resources. And again, of course, we would propose, why don't you use queues to get rid of that and get rid of the availability constraint and so on. But still, you have the multiplication of effort. You now have the location dependency on all those queues that you have employed. What is the way out of this? Yes, it's the pub/sub channel that you can use instead. And with that, you only have to send out that event one time to the pub/sub channel. And the pub/sub channel distributes it to all the registered subscribers to it. And this is totally transparent to the order service. In this case, all the consumers, subscribers on the right-hand side can do this on their own. And the order service doesn't have to be aware of it. So that's all great. But unfortunately, we now got rid of all the goodness that the queues gave us. And we will have a look at how we can solve this in 30 seconds. But before that, there's one question left. When we use the pub/sub channel in an event-driven architecture, should we use topics or should we use a bus? And that is, again, a talk all on its own, which can take easily 60 minutes and so on. So TLDR, for event-driven architectures, our recommendation is to start with a bus, and only if that doesn't fulfill your requirements, then consider the application of topics. Now, how to get the best of both worlds? Quite simple. You can do a topic queue chaining or a bus queue chaining. You just chain the pub/sub channel and the queues. Then you have the concurrent consumer functionality. You can get rid of the availability constraint, and you still are able to fan out your messages to all those interested consumers. So that's great. What service do we have at hand? We said we recommend a bus for pub/sub in an event-driven architecture. And the recommended service for this would, of course, be Amazon EventBridge. Again, cloud-native, serverless, managed service for what we call an event bus. And it integrates also with 31 AWS services as consumers. So that's quite comfortable to get. And also, it comes with API integrations to SaaS solutions. So it's really super helpful to set up your event-driven architecture with Amazon EventBridge as the backbone of it all. Then there's that other fan-out integration pattern that I mentioned in the beginning, which is streams. And streams are actually made and created to take care of unbounded data, of more or less continuous, never-ending streams, hence the name, of data items. And there's actually a difference between messaging and streaming, which creates a whole lot of confusion all the time. It's quite ambiguous also, since the functionality for existing products converges over time. But to get the difference of what is actually meant to be message processing and what is meant to be stream processing, we have a picture here in two versions. It shows my colleague Christian Müller and me, like a few hundred meters above Mos Eisley spaceport. On the left-hand side, you see the full picture. And for messaging, that would be the content of the message. So that's the unit of work. We are interested in every message, and every message has a meaning for our processing. While in streaming, it's not that one tile of that picture, it's the entirety of those tiles that have a meaning. So if we consume a batch of messages that contain all those tiles, only then we get the big picture. A single message doesn't really have a lot of meaning to us. We typically want to observe several messages, a batch of messages. And then there's also a difference in the consumption model. So with messaging, as soon as you consume a message, it's gone, right? It's going to be deleted. And with streaming, the messages remain in the stream, and you can also go back in the stream and whatever. This is also the reason why you have to maintain that cursor on the stream. Now, there used to be that unique selling point of streams that you can actually do replay. And since a while, archive and replay functionality also came into messaging, like Amazon EventBridge and Amazon SNS 5.4 topics offer that too. That just adds more of the ambiguity and the discussion about when to use what, but still the consumption model remains differently in messaging, as you can see here. What would be a good use case of streaming in an event-driven architecture? Change data capture would be one good example. If you look at Amazon DynamoDB, there's that additional service next to it, DynamoDB Stream. And if you just want to send out downstream events about changes in your database without actually having to code it, you can also shift the responsibility for that just to DynamoDB and DynamoDB Stream, which will send out those events downstream to a receiver, and you can actually also, if you want, you can directly connect it with Amazon EventBridge through EventBridge pipes and transform it there and get it into your common format. So that was an overview about fundamental integration patterns. Now we look into some advanced ones.
Mm-hmm. As we zoom out again and we go back to our EDA journey, we will see that there are some questions that come up in the journey, maybe by your teams, maybe you start to wonder yourself, and there are some patterns as well, as Dirk mentioned, that are useful to keep in mind. So the first question that arises when we start working with event-driven architectures is, what should go into this event, right? What should we place there? And especially when we want to communicate across boundaries, and we, as the orders domain, we think, okay, I'm going to raise the event this way, and maybe the first consumer comes around and says, okay, that's not a lot of information, it's a bit small, but I'll accept it, I'll use it as it is, because if I need more information, then I'll simply go back to you and ask for it, and I'll get that information. And what we see here is that we, as the order service, produce some event. It went into our event bus, got to our consumers, and then they decided indeed to go back for more information, to call us back. In this case, as you see there, via API call or via REST API. And we're introducing some form of accidental coupling like this. What happens there is that as we scale our consumers, or we add new consumers on the right-hand side, we apply some back pressure to the order service. And at first, this might look like we are actually getting more requests into the order service. We see some HTTP requests coming in, and we think, oh, we are actually growing as a business. We have more orders coming in. And in fact, it's simply just consumers coming for more information. And this is not a request-response pattern. This is simply the consumers reaching back at the moment they are processing the event. And this could be a valid pattern. For example, if you know there will be some delay in processing, and at the moment in which the message gets processed, those consumers really need real-time information from the orders domain. That could be a valid pattern, but the gist here is that you should be mindful of not falling into that accidental coupling via callbacks. Talking about requiring more information than what comes along in the event, or enriching those events, we have the content enrichment pattern, and this helps us with this problem. And what it says is that it helps us keep the producers simple in contract. They can produce an event with a simple model, and the enricher will say, okay, I will receive those events, and I will be the one taking care of doing that enrichment, adding that information. And only then I will send it on to the consumers. So pretty useful. And if you're using EventBridge already or would like to use EventBridge, we have a feature called EventBridge Pipes that helps us implement this pattern. EventBridge Pipes basically connects source and target service, and it will take care of doing this enrichment with the use of other AWS services such as AWS Lambda, step functions, and others. An example of this is, for example, the changes in an Amazon DynamoDB table. We can use change data capture to get those changes, raise an event in that case that goes to EventBridge, and then we have the different, up to 14 different AWS services supported as targets. In the middle, it's event bridge pipes that will do the enrichment and that add any necessary information. So that's pretty useful. Another problem or question that might arise is, how do we deal with things when our payload is rather large? So I want to raise an event, but my payload is really pretty big. How do I do that? It actually breaks the limit or goes over the limit of what my middleware allows me to send. Let's take, for example, Amazon SQS or EventBridge as with their 256 kilobyte limit as examples. We have also a pattern for this, the claim check pattern. And what it tells us is that the producer can, before it sends the event, store that big payload in a separate location. It can go and say, for example, in Amazon S3, I'll store the payload there, and I will emit an event only providing a key or a reference to that larger payload. If we implement this with serverless, we could have a Lambda as the producer, and as I mentioned, S3 as the location where Lambda, before emitting the event, will store that larger, for example, document or different type of object, and then include a key to that object, or maybe a pre-signed URL. In the event that goes to EventBridge, EventBridge will automatically trigger a step functions workflow, and as part of the workflow, step functions will go to S3, fetch that larger payload, and then work with that and continue the workflow. So that's an example of how it can be implemented. Another problem that might come down the line is the coupling through contracts. So as we integrate different domains, we start to raise events, and we will typically fall into one of these patterns of integrating across domains. The first one is the conformist. So we, as System A, the producer, produced an event, and System B, who is the consumer, takes it as it is. It just uses it the way it received it. And like that, it's coupling itself to the producer, because producer A might be sending its own language or its own implementation details across in the event, and B simply conforms to that, hence the conformist sort of pattern. In order to avoid this kind of coupling, we can introduce an anti-corruption layer as the consumers. We say, yeah, OK, you send that event, but I won't take it as it is. I will transform it into something that I understand, into my own domain language. I will isolate all the information that you passed along, which it does not concern me, and like that I will decouple myself from your model. The reverse of that is the open host service. So instead of just raising the event, it is service A that will take care of passing only the information that is of concern to the consumers. So we'll transform its own model into a public language, a public understanding that other services will be able to understand without getting private information. And this is pretty useful when the events that, for example, producer A generates are of interest to multiple consumers or enable cross-cutting concerns in the organization. What we will observe also with these patterns is that depending on the one that you adopt, there will be different levels of communication required. With the open host service, we will need to do that communication up front. So we will need to agree what kind of information can flow across domains in the organization and establish a universal language. And down the line, we will see that because we did that work up front, changes in schemas and changes in integration across domains don't really require any communication across teams. Whereas with the conformist pattern, you will see that you'll constantly have to be thinking, if I do this schema change now, or if I introduce this property or remove another one, am I going to be breaking consumers in production? So you will need to keep talking to other teams highly or often with the conformist pattern. And there are more patterns for what we call context mapping. So how do different bounded contexts communicate with each other? And with the resources there, I encourage you to check that out as well. One takeaway from this section is perhaps that having producers, consumers, and message brokers doesn't actually make us event-driven. Event-driven is a collection of patterns, the ones that we are talking about now. And these are well complemented with domain-driven design, with practices like event storming, as Dirk mentioned. Another aspect that often gets lost in the conversation of event-driven architectures is operation and maintenance. And what we observe when we start in this EDA journey is that we're promised this low complexity and high agility, and at first we get that. We are able to scale and add new features in our architecture without talking to many other parties. We simply just start reusing the events that are flowing around. And with time, we see that complexity starts to increase, and the agility maybe also starts to decrease. And if we are really unlucky, we might end up in number 3, and then we start to question why we do this in the first place. And as you read more about event-driven architectures that are more familiar with the literature, you will often hear this phrase: producers should not know about consumers. And that is right, but that doesn't mean we can skip governance altogether. When we talk about governance, there are some aspects, particularly around operation and maintenance, that are pretty important to keep in mind. So these 3 pillars here I'd like to discuss, starting with the standards. What we mean with the standards is agreeing on some things like metadata that we want to enforce in our events. What kind of properties do we want all our events to have so that we can enable tracing and observability across domains? Can we, for example, create utilities and libraries in the different programming languages that are in use in the organization to enforce this metadata? And thinking about standards also means a shift in mentality. So moving to an event-first thinking approach. If we look at how we deal with APIs in organization, we like APIs, we document API, we version APIs, we publish APIs, and when it comes to events, we somehow think that we can have a total absence of that, and it's not really the case. So this shift in mentality is something that we need to also incorporate, and there is this very interesting talk from our serverless colleague, David Boyne, that discusses on how to move to that kind of thinking and how to incorporate learnings across in the process. The next aspect is discoverability. Where are the events? What events are flowing around? Can I reuse those events? And the documentation, because that helps us also discover. And EventBridge, of course, has this pretty nice feature, which is called schema discovery. This is something you can enable in your buses. And as events flow through, it will go ahead and document the schemas of your events in the schema registry. It will actually version or create versions in the schema registry as your payload changes or as your schema changes automatically. And if you go to the schema registry, you can also download code bindings for different programming languages. So that's pretty useful. In terms of documentation, there are open source projects that you can look into. Async API is one of them, and I also encourage you to look at Event Catalog by our colleague David Boyne as well. This actually generates a static site for you for your event-driven architecture. So it will document producers, consumer events, and also a visualization of the integrations. The last one is communication. We talked about this ubiquitous language or universal language in the organization. Take the time to agree on that language with methodologies such as event storming in order to hide what should remain in the different domains from what should be the language speaking or the common understanding that you speak in the organization. This will also help you keep clear boundaries. And the takeaway here for this governance section would be that it's these standards, this discoverability and communication that will help you stay in the upper left corner. And like that, keep your architectures really evolvable. If you want to learn more, we have, of course, resources for you. Scan this QR code to get to our landing page with multiple resources, including EDA visuals. This is bite-sized visuals to learn the different concepts in event-driven architectures. Very, very nice. You can also learn with training and certification from AWS and hone up your skills, including through a skill builder. So if you want to create your account, highly recommend it as well. Lots of free training. And if you didn't already do so, please install the mobile app. even though it's the end of the day, so you can provide us feedback. We'll really appreciate some feedback for this session. It's the feedback that helps us create more and good content for you. So with that,
also, please feel free to reach out to us either directly after this talk or via LinkedIn or Twitter if you want to discuss any integration or EDA question. Thanks a lot for coming.
Thank you.